Hello learners, I welcome you to this lecture on significance of ocean temperature and its measurement. Expected learning outcomes. After viewing this video program, you should be able to define ocean temperature, discuss the different properties of seawater, describe the significance of studying temperature of the oceans, and explain the techniques of measurement of ocean temperature. So what is ocean temperature? Ocean temperature refers to the heat content of water of the oceans, and it varies across different depths of oceans and different regions also. It is a key factor in regulating Earth's climate as the ocean absorbs, stores, and distributes heat more effectively than the atmosphere. Ocean temperature is one of the most fundamental physical properties of the seawater. Now, what are the physical properties of seawater? Physical properties are described as the physical behavior and characteristics of seawater like temperature, density, salinity, pressure, viscosity, surface tension, etc. And what are the other properties of seawater? They are called the chemical properties of the seawater, and it describes the chemical composition of and reactions in seawater like dissolved gases, pH, nutrients, ions, etc. So in this block, that is block 3 on oceanography, we are studying the properties of seawater, especially the physical properties of the oceans, that is the temperature, density and salinity. And this video program is related to temperature of the oceans. What is the significance of ocean temperature? The temperature of the ocean is primarily affected by solar radiation, ocean currents, wind patterns, and geographic location. The surface temperatures fluctuate more due to daily and seasonal changes, while the deeper waters remain more stable but are influenced by long-term climate trends. The ocean is divided into three temperature layers: the surface or the mixed layer, which is from 0 to 200 meters, that is from sea level to 200 meters depth; the thermocline, that is from 200 meters to 1000 meters depth, and the temperature decreases rapidly here in the thermocline layer; and the deep ocean, which is below 1000 meters and which remains relatively cold and relatively uniform. Now, we study the significance of ocean water, like what it does and what are the effects of ocean temperature. So, ocean temperature controls the density and water column stratification. Temperature directly affects the density of seawater just because warm water is lighter or less denser and cold water is heavier or more denser. So this difference in density leads to stratification, that is creating of layers such as mixed layer, thermocline layer and the deep water, as I've just now told you. And stratification influences the vertical movement of water, nutrient mixing and overall ocean circulation. Due to ocean temperature, oceanic circulation and climate is also affected. Ocean temperature drives the thermal gradients which are essential for global circulation systems, that is thermohaline circulation. Warmer equatorial waters and cooler polar waters create temperature contrasts that help transport heat across the planet. This redistribution of heat moderates global climates and affects the weather patterns like monsoons, cyclones, droughts, and rainfall variability. Now, due to ocean temperature, also marine life distribution and its productivity is affected. So each marine organism has a specific temperature tolerance range. So temperature determines the distribution of phytoplankton, coral reefs, fish populations, and other marine species. Upwelling of cold, nutrient rich water supports high biological productivity in regions like eastern boundaries of the oceans. Ocean temperature also influences the chemical properties of seawater, like temperature determines the solubility of gases, for example, oxygen, carbon dioxide, etc., in seawater, and colder water holds more dissolved gases. So, temperature affects the chemical reaction rates, pH, salinity, and carbonate chemistry. You know, carbonate chemistry is important for shell formation of the ocean, and it is also used in ocean acidification studies. Sea temperature also affects the sea level changes, like warmer water expands due to thermal expansion, and it contributes significantly to the global sea level rise. The rising temperatures also accelerate the melting of ice sheets and glaciers, which adds more water to the ocean and thus changes the sea level. Temperature is also essential for weather and storm formation. You must have read in climatology that warm surface waters that is greater than 26 to 27 degrees centigrade are necessary for the formation of tropical cyclones and hurricanes. So temperature gradients between air and sea influence heat exchange, evaporation and cloud formation. Temperature of ocean water is also an indicator of climate change and variability. Changes in sea surface temperature SST are key indicators of global warming. SST anomalies help detect climate events such as El Nino, La Nina, which have global impacts on rainfall, agriculture, fisheries, and other disasters. Now, do you know how the temperature of ocean is measured? Let's study in this section. Ocean temperature is measured using various techniques ranging from satellite observations to direct in situ measurements taken at different depths. These methods help scientists monitor short-term variations and long-term climate trends. Now, how satellites measurements is done? Satellites such as NOAA's or National Oceanographic and Atmospheric Administration AVHRR, Advanced Very High Resolution Radiometer, and NASA's MODIS. NASA is National Aeronautics and Space Administration, and MODIS is Moderate Resolution Image Spectroradiometer. They use infrared and microwave sensors to measure sea surface temperature globally. These instruments detect the emitted radiation from the sea surface, providing continuous large-scale temperature data. Satellite measurements are also essential for taking ocean heat content, El Nino events, and climate change trends, but are limited to surface observations. Now, we have also Argo floats. So, Argo program consists of about 4,000 autonomous drifting floats deployed globally to measure the ocean temperature and salinity at various depths, up to 2,000 meters depth. These floats transcend and ascend periodically, transmitting data via satellites. Argo floats provide crucial information about subsurface ocean temperature trends, ocean circulation, and climatic variability. In this figure, you see Argo floats 10-day mission cycle. So you see the Argo floats are drifting to about 1 kilometer depth, 2 kilometer depth, and they begin to take temperature, salinity, and pressure readings during the ascent. and then they reach out to the surface and provide the readings. There are also ship-based observations, or we can call this expendable bathythermographs, XBTs. These are deployed from ships to measure temperature profiles in the upper ocean up to only 1500 meters depth. Conductivity temperature depth, CTD sensors. These are used in research vessels to gather highly precise temperature and salinity readings at multiple depths. These ship-based measurements are detailed but limit in geographic coverage compared to satellite data. This figure shows the expendable bathythermographs XBT auto launcher. We have buoys and moorings also. Fixed buoys and moored instruments continuously record temperature data in specific locations such as NOAA's Tropical Atmospheric Ocean TAO array, which monitors the Pacific for ENSO or El Niño Southern Oscillation events. Coastal buoys provide real-time temperature monitoring for weather forecasting, fisheries and marine safety. We have now underwater gliders and autonomous vehicles. These are a kind of, robotic vehicles and are designed to navigate through different ocean depths, collecting temperature, salinity, and other oceanographic data. They provide a more flexible and efficient means of studying temperature variability in the remote regions. We also have oceanographic research stations. This is actually done for long-term ocean temperature trends, which are monitored from permanent research stations and deep-sea observatories. These stations provide high-resolution time series data crucial for understanding ocean atmospheric interactions. Each of these methods play a crucial role in monitoring ocean temperature and understanding its impact on global climate and marine ecosystems. Combining, multiple approaches can be combined, and this would ensure comprehensive and accurate temperature assessments, which are essential for climate modeling, disaster preparedness, and sustainable ocean management. So in this video program, we have studied about the significance of studying ocean temperature and the ways and techniques to measure ocean temperature. Thank you.